Let's simplify some cube roots. Now, the process that we'll use to simplify cube roots is much like the process that we use to simplify square roots. There's only one slight difference. Just like when we were simplifying square roots, there are 4 criteria that must be met for a radical expression to be fully simplified. 3 of those criteria are exactly the same. The radicand can't be a fraction, it can't be negative, and we can't have radicals in the denominator of a fraction. The one that's a little bit different is that when we're simplifying cube root expressions, the number underneath the cube root symbol can't be evenly divisible by any perfect cube other than 1. That's a little bit different than the square root problems. Remember, when we were working with square roots, the number underneath the square root symbol couldn't be evenly divisible by any perfect squares other than 1. Now that we're working with cube roots, the number underneath the cube root symbol can't be divisible by any perfect cubes other than 1. So let's look at the one over here on the left. 4 times the cube root of 54. The cube root of 54 is not fully simplified. I have a hunch that it's going to be divisible by a perfect cube. So let's see if we can find the biggest perfect cube that will evenly divide 54. I've listed some of the perfect cubes from smallest to largest in the middle of the screen. 8, 27, 64, and 125. Because we want to find the biggest perfect cube that will evenly divide 54, let's start at the top and work our way down. Is 54 evenly divisible by 125? Obviously not. 125 is way too big. So let's go down to the next one, 64. 64 is still larger than 54, so 54 is not evenly divisible by 64. Again, obviously. Will 27 evenly divide 54? Yes. 54 divided by 27 is 2, or another way to say that is 2 times 27 is 54. So let's rewrite the cube root of 54 as the cube root of 27 times 2. Now, using the multiplication property of radicals, we can rewrite that expression as 4 times the cube root of 27 times the cube root of 2. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So that gives us 4 times 3 times the cube root of 2. 4 times 3 is 12. So that gives us 12 times the cube root of 2. Now we have to look at the cube root of 2 and ask ourselves, is the cube root of 2 a fully simplified radical expression? Well, 2 is not a fraction. It's not a negative number. It's not a radical in the denominator of a fraction. And it's not divisible by any perfect cubes other than 1. So yeah, the cube root of 2 is a fully simplified radical expression. And 4 times the cube root of 54, when fully simplified, is the same thing as 12 times the cube root of 2. Let's look at the example over on the right, the cube root of 320. Let's start by finding the biggest perfect cube that will evenly divide 320. 320 is a pretty big number, so I'm going to increase our list of perfect cubes in the middle of the page. In the previous example, I stopped at 125, which is 5 times 5 times 5. But let's go up another notch to 6 times 6 times 6. That's 216. 216 is more than half of 320. So that should be plenty high for us to find the biggest perfect cube that will evenly divide 320. So, will 216 evenly divide 320? No, of course not. Does 125 evenly divide 320? No. Does 64? Yes. 64 times 5 gives us 320. So 320 is evenly divisible by 64. So let's write the cube root of 320 as the cube root of 64 times 5. And using the multiplication property of radicals, we can rewrite that as the cube root of 64 times the cube root of 5. And we can simplify the cube root of 64 as 4, because 4 times 4 times 4 is 64, so the cube root of 64 is 4. That gives us 4 times the cube root of 5. Now we have to direct our attention to the cube root of 5. Is that a fully simplified radical expression? 5 is not a fraction. It's not negative. The cube root of 5 is not in the denominator of a fraction. And 5 is not divisible by any perfect cube other than 1. So our radical expression is fully simplified. So the cube root of 320 is the same thing as 4 times the cube root of 5.